In this video, we will see continuous cooling transformation diagram. It is also called as CCT diagram. So this diagram is derived from TTT diagram. You can see this blue color line, dashed line is a TTT diagram, and here this red color line is called as continuous cooling diagram, because in this diagram we cool it at a fixed cooling rate. So in TTT diagram, cooling temperature is fixed. So we fixed the cooling temperature, and at that temperature we develop some microstructure. But here in CCT diagram, the cooling rate is fixed. Like cooling rate is 140 degrees Celsius per second and 35 degrees Celsius per second. So at different cooling rates, from gamma austenite at 727 degrees Celsius, we achieve different microstructure with different cooling rates. So from this temperature we cool at some rate and we bring it to the room temperature. So that is how we can get different diagrams. So the first point is, in this diagram the Banach structure does not forms. So here in this CCT diagram, only perlite and martensite is formed. So this red color line on the left side is called as an austenite start, means starting of austenite decomposition into the perlite. This particular line is a 100% decomposition of austenite into perlite. So in this region we get a perlite. Now after touching this nose, from this point if we cool it and we just touch this point, so this particular cooling rate is called as critical cooling rate. Inside this region we get a martensite structure, and we get it by water quenching. So on the left side of this curve, all the cooling rate will get a martensite structure, and up to this point we get a martensite structure. After that it will enter into the perlite zone. So this is a decomposition of the perlite. So here from austenite to perlite structure forms 100% at this point. Now in between these 2 points, if we cool, then we get martensite plus perlite, and we get it by oil cooling. This blue line is a martensite start line, and this line is martensite finish line. So from here martensite structure will decompose into austenite will decompose into martensite. So in this region, if we oil quench it with this particular cooling rate between 35 to 140 degrees Celsius per second, we get martensite and perlite microstructure, both in combined. After this point we get a perlite composition 100%. So by normalizing or air cooling, we get a perlite which is fine perlite. So fine perlite is little bit brittle than coarse perlite, but it is more ductile than martensite and martensite plus perlite. So this will be more ductile and tough. And after that, if we cool it very slowly, means very slow cooling rate we give, then we get full annealing and we get a coarse perlite structure. And the important point in this diagram is the nose of the curve shift little bit downward, means at less temperature, and also it shifts towards the right, means the incubation period increases for perlite transformation. So another point is Banach structure does not forms in this CCT diagram. Thank you for watching this video. We'll see you in the next video.